Hey guys, welcome back. So in last video we have seen that array list, linked list, stack and queue implementations, right? And also we have seen that the method which we need to use in those classes. Now we are going to see the hash set and hash map class, right? So before starting with hash set and hash map, we need to understand the hashing concept, because the hashing concept is very much important if you really want to know what happens behind the scene when you store the data in the hash set or in the hash map, right? So first I will cover hashing, and then we'll go with the hash set or hash map classes in collections framework. So we'll start with hashing here. What is hashing? So hashing, if you look at hashing is the process where your object will get converted into an integer by using a method called hash method, right? Sorry, by using a method called hash code method. So basically what happens, this hash code method we have in the object class. So these methods are overridden from the object class. So whenever you create any object, by default that object will have the facility where we can call hash code method on the object, because you know that whenever you create any class, your class will extend object class. So you have this hash code available always, right? Now hash function should return the same hash code each and every time when the function is applied on same or equal object. So whenever you have created multiple object, right? Whenever you have a multiple object of the same type, or let's say you have same object, right? You are just changing the reference, but you are assigning the same object. In that case, for all the object, your hash code will not change. I will show you through example, you will understand. That's what I'm writing here. Like whenever you will call hash code method, the always the address of the object will be the same. In other words, two equal object must produce same hash code consistently. Okay, so whenever you have a two equal object, when you make a call to this hash code method, it will never change. So first we will try to understand the hash code concepts, and then slowly we will move towards hashing, how it happens, how data storage happens in the map classes, right? So look at here, we have designed one class. Okay, so let me go to the Eclipse and I will show you like how this hash code will be common when object is the same, and how the hash code will be different when the object is different. So let's start with that. So look at this class here. We have hash example called hash code example 1, right? So as I was talking about this hash code method, we can override from the object class. So here just I have written, I did not do anything, I just wanted to show you. So you can just write hash code, control spacebar and click on hash code. So when you write like this, automatically this method will get overridden from the parent class, from the object class. So here you can change the implementations of the hash code. As of now, I'm not going to change the implementations of the hash code. I'm not going to do any custom coding here. Just I wanted to show you that's how you can override the method from the parent class to child class. That we have seen that in the polymorphism also. Now for this class, I am creating the object, right? So this is the object, right? And also I am creating two string object. So here I am creating two string object. So what happens when you create the object like this? Basically, if you look at whenever you create any object, behind the scene what happens? So there will be something called stack area. Stack area is the one where your reference will get created, right? And then there will be something called heap area. So this is your heap, assume that. So this is your heap and this is your stack, right? I can write here stack area and this is your heap area, right? Now when you have created the very first object, the reference will be here. So what I'm trying to say that is, when if you look at this code example 1, this is the reference and this is the object, right? So how this will work is, This code example 1 reference will be here. Code example 1, and in the heap area this guy will occupy memory. So now this reference will point here, right? So and this this memory has some address. So assume that this memory has an address of 100, right? This memory has an address of 100. Now come back. You are creating two more object of the string class. So in a string class we can create the object like this without using new keyword. So what happens in the string class when we create object without writing new keyword? So basically what happens in your heap area, there will be something called constant pool. So whenever you don't write new, you just create the object of the string. In the heap area there will be something called constant pool. So we call this as constant pool. Okay, constant pool. So this is the constant pool. In this constant pool, your object will get created with the data called test. Okay, so whatever you are seeing, that this test will get created, and s1 will point there, right? So another reference will be where it will be in the stack s1, and this guy will point the data in the constant pool. Now what happens when you create s2, okay, so in a string again you are creating one more object of the string and you are just writing test, right? You are not using new operator, right? So this is also we can do that. So what happens is, let's say either you do like this or you write here new string and in parenthesis you can write like this, you can create another object, right? So let's say 3 object here, right? So now s2 is test, s3 is test, all are test. So basically what happens for s2, your reference will be in the stack, okay, and this s2 will also point to the same test present in the constant pool, okay. This guy will also point the same thing present in the constant pool. Now when you have created one more called s3, sorry, I'm facing some issue. So when you create again s3, now what happens is this s3 will not point to the test in the constant pool, because whenever you write a new operator, okay, whenever you write a new operator, what happens is in the heap one area will get allocated whenever you write new, and now s3 will point here to this object, okay. S3 will point to this object and this object has data is equal to test. Got it? Now this s3 object will not get created into the constant pool. This will not get created in the constant pool because we are writing a new operator. So new operator will create object in the heap area in the non-constant pool, not in constant pool. It will be in the non-constant pool. Now what happens? This object, let's say address has 200. So now s1 address will be 200 and s2 address also will be 200, but for s3 this address will be 400, okay. This address will be 400. Clear? Let me erase this. This is not looking good. Yeah, and then correct, right? So now so you can see that, right, like how the object creations happens in the memory, and how when you use a string without new keyword it will get created in the constant pool, and when you use new keyword it will get created in the non-constant pool, okay, in the memory. And then every object has an address. So till here we are clear, we are aligned. Now come back. Now what you did, you created one more reference of the class, this example 1, code example 2, and you are assigning example 1 reference to the example 2. So you are assigning the first object to the second object. Now what will happen? The code example 2, so basically here what happens in the stack, one more data entry will happen, and there will be something called code example 2. So here it will be code example 2. Okay, there will be something called code example 2, and this guy will also point to the same object. This guy will also point to the same object, right? So code example 2 will also point to the same object, right? Come back. Now there is something called code example 3, but here what happens? In code example 3, you are creating with the new. So now the code example 3, when you go here, so what will happen? In a stack again, one more entry will go code example 3, and here the new area will get allocated in the heap for example 3, right? So let's say after this one more entry will go to the stack, and let's say here it is example 3 will point to this, and this has a address of 500. so now you can see that example 1 has the same address. S1 S2 has the same address. S3 has the different address. Example 3 has the different address. Clear? Like how object creations happens in the memory. Now come back. You just, now whatever I told, if you want to understand everything, just what you can do on every object whatever you have created here, you can just call hashcode method. Hashcode method will give you the guarantee that whatever I explained till now, it is in the same conditions or not. So on every object you just call the hashcode. Hashcode is nothing but the integer value of your memory, integer value of your address. So whatever address I was showing into the memory, the same will get converted to the integer data, right? And then you are calling the hashcode on the string also. Now let me add one more thing. Let me add S3 also, because I have just now added. So you can see here S3 and S3. Now let's run that. See, okay, let me run one more time. I was printing the object, I did not print the hash code for one of the example. Now look at here. First three you focus. For example 1 and example 2, this is your example 1, this is your example 2, has the same address as I was explaining in the diagram also. Example 2 and example, see this example 2 here, the example 2 which you have here and example 1 you have here, both if you look at this guy pointing to this object and this guy also pointing to this object, so address will be same, right? If you look at your address is same. Now example 3 different address, here example 3 different address. The reason is this example 3 when it came to the stack, okay, this guy is pointing to this object and this guy address is 500, right? Now come back, this is the notes. Come back. Now this string S1, S2 and S3. So S1 and S2 will have the same address. So if you look at here, S1, S2 and S3, okay, S1, S2 and S3 all will have the same address. If you look at here, ideally it should not be the case. See, though the address is same, so if you look at here, you are calling that s1 dot hashcode, then you are calling that s2 dot hashcode, and then you are calling that s3 dot hashcode. So here, why for all three the memory address is same, okay, 3556498, 3556498, 355564988. okay, it's not same. Even I was thinking internally why it is coming same. No, actually it is 355 6498. So actually it is same. Okay, it should not be. Ideally, why I was saying that it should not be, because as per logic, if you look at here and if you write SO, when you compare S1 and when you do is equal to S3, this will be false. Okay, it will compare the reference. See, this is the false. Okay, it compares the reference, so it should be false. Ideally, hash code is derived based on some other logic, and I will tell you why it is same also. Okay, if you just change the string here, the hash code will be different, but here the hash code is same. The reason is basically what happens in the memory. I'll explain you. Okay, give me a time, I'll draw the diagram and then I'll explain you. So this is a part of a string class, but I will try to give you some idea like how this works. Guys, now you will understand very well. This is a part of a string, but I will give you, since you are getting that the same hash code. So basically what happens, whenever you create an object of a string without using new keyword, the data will be there in the constant pool, right? This data, the object will get created in the constant pool, and again if you create s2 with the same data, this s2 will point to the same object in the constant pool, which you can see that. But what happens when you are creating a s3, okay, with the new operator, the object will get created in the non-constant pool. This is non-constant pool in the heap area, but it will check the content, this object, okay, it will check the content in the constant pool. If the content is there in the constant pool, it will point to the same content. That's how it works. Object will be here in a non-constant pool, okay, non-constant pool, but content, it will be if the content is present in the constant pool, it will point to the same content. Let's say if the content is different, let's say instead of test, if it is a test1, then test1 will get created in the constant pool. That's how it works. So always content will be in the constant pool. That is the reason when you make a equal operator call on this two object, you are getting it false. But when you make equal operator on this s1 and s2, you will get true, because here the object is also in the constant pool, but s3 object in the non-constant pool, data you have in the test. So why the hash code is common for all three? Because for hash code creations there is a different logic altogether. Okay, there is some algorithm which runs behind the scene to create the hash code. Okay, but reference will be different for all three. So now come back, and whatever I did here, s1 and s3, same if you will try s1 and s2. So basically this equal operator will check for the reference of the object. Okay, and reference are different. See here, you are getting that true. So when you called s1 s2, you are getting that true, but s1 s3 you are getting it false, because for s3 reference is in non-constant pool, data is in it is fetching from the constant pool. That is the reason for all three, if you look at, the hash code is same, right? Because the string is the exceptional things. You have one memory is the constant, one is non-constant for your performance things. That I'll cover in the details when I will talk about a string chapter, not here. My intention not here to teach you the string. My intention is to teach you what happens when you have two objects same and what happens that is different. So now you can look at here, hash code was same, here the hash code was different. In case of code 1, this has one hash code. In example 2, if you will keep the same reference here, this has same hash code. If you will create one more object, this will have a different hash code. That is the reason for example 1 and example 2 has the same hash code. Okay, but example 3 has a different hash code. Again for s1 s2 it has the same hash code, but s3 will have the s3 also has the same hash code. The moment if you change here test1, now for s3 hash code will be different, right? Now hash code will be different. See here, hash code will be different for the s3 because you have changed the content, so hash code will be different, right? Now with this I will close this video. You got an idea of how through hash code you will come to, I mean how when you have a common object how the hash code is common, and how you have a different object the hash code is different, right? Because first I wanted to give you the idea of how hash code works, and how you have same object has a same hash code, different object has a different hash code. Now we will see some more concept in this hashing. Thank you guys, thank you for watching this.